Hello dear students. In the previous video we saw what is matter and the concept of diffusion. So in this video we will see that what are the states of matter. So you know that any matter or the matters can be present in three different states, that are solid, liquid and gaseous state. Actually the matter can be present in five different states. There are two other different states on which the matter can be present, including solid, liquid and gases. So about those two different states you will study in the higher classes. So for now in standard 9 we will study about the solid state of matter, the liquid state of matter and the gaseous states of matter. So matter around us exists in three different states, that is solid, liquid and gas. These states of matter arise due to the variation in the characteristics of the particles of the matter. So as the characteristics of the matter changes, the matter can be present in solid state, they can be present in liquid state or they can also be present in gaseous state. So what are the characteristics of the matter? So generally there are two characteristics of the matter that decides that whether the matter will present in either in solid state, liquid state or gaseous state. So those properties are the intermolecular force of attraction and the intermolecular spaces. So what is intermolecular force of attraction and what is intermolecular space we will see here now. So suppose we consider a matter. Suppose this is a matter. So this matter is made up of tiny atoms and molecules. So this matter is made up of tiny atoms and molecules. Okay, as you can see here. So all these are molecules. So in case of solid, this gap between two consecutive molecules is very small, so that they bind each other with a very high force. Okay. In case of liquid, the gap between two consecutive molecule is moderate. They are binding with each other with some force, that is intermolecular force, but that force is not strong enough as compared to the solid. It can, so in case of gas, the molecules, the force of attraction between the consecutive molecule is very less, so that they can randomly move here and there. Okay, so in this case this becomes solid because the force of attraction among molecules is very high. Why the force of attraction is high? Because the intermolecular space is very less. To make you understand, let me give you a very small example. Suppose you have a magnet. Suppose this is a magnet. Now you have a piece of iron. Suppose this is a piece of iron. When you bring this piece of iron near to the magnet, what will happen? The magnet will pull the piece of iron. So as the distance between the magnet and iron decreases, the force of attraction increases. Similarly, when the distance between the two consecutive molecules decreases, the force of attraction increases. Okay, so in case of solid, the force of attraction is maximum. In case of liquid, it is moderate. In case of gas, it is very less. On the other hand, in case of solid, the intermolecular space is very less. In case of liquid, it is moderate. In case of gas, it is very high. So let us continue this concept. The first state of matter is the solid state. Now these have a definite shape. Solid have a definite shape. You can take a glass from your kitchen. This is a solid. It is having a definite shape. You can see your mobile phone, on which nowadays you guys are generally play PUBG and Free Fire and all that games. So it is having a definite shape. You can see something like your cricket bat, it is also having a definite shape. So any solid, the solid is having a definite shape. The distinct boundaries are and fixed volume, that is have negligible compressibility. They do have a fixed boundary and fixed volume. That means this glass, it is having a fixed boundary and it is having a fixed volume. What is the boundary? Boundary is the outline of the glass. Okay, what you can see, that is boundary. Okay, the amount of material that can be present inside the glass, that is the volume. So it is fixed. You cannot take a glass and pour 10-liter water into it. Can you? You cannot. Okay, so it is having fixed boundary and fixed volume. That is, they have negligible compressibility. Compressibility. What is compressibility? How much you can compress a particular matter. That is compressibility. Suppose you take a balloon. You take a balloon and blow it. Okay. Now you can easily compress the balloon. But rather taking balloon, if you take a solid, for example, a piece of wood, will you be able to compress it? No, you will not be able to compress it. Here, in this case, the balloon is having air, so its compressibility is high. This is a completely solid. So here the compressibility is very low, or it is negligible. So they do have negligible compressibility. Third point, solids have a tendency to maintain their shape when subjected to outside force. That means if you take a piece of solid and if you try to compress it, okay, so it will not change its shape and size. Okay, so solid have a tendency to maintain their shape when subjected to outside force. So if you apply a small amount of force, then nothing is going to happen with the solid. But if very high amount of force is applied, the solid may bend itself, may get bent, or it may break. Okay, but it will not change its size and shape as liquid changes. Next point, solid may break under force, but it is difficult to change their shape. So they are rigid. Now suppose you take a piece of wood. Now you cannot change the piece of wood by applying some force, although you will be able to break it. Now the one question might come into your mind, that rather than taking a piece of wood, if you take a piece of iron, with the help of certain force you can bend it. So here what it is written, it is difficult to change their shape. Here it is not written that it is impossible to change their shape. Yes, it is difficult, but it is possible. So again the solid is divided into two types, different types. One is brittle solid. Okay. Again there are different types of solid, so we'll deal with the different types of solid, like ferrous solid, non-ferrous, metal, non-metal, and all that. In the coming classes we will deal with that. Okay, so our second state of matter is the liquid state. Liquids have no fixed shape but have a fixed volume. For example, water. So you cannot directly tell that the water is having which kind of shape. It takes the shape of the container. This is a glass. You can pour water inside the glass. The water take the shape of the glass. Now suppose this is a plate. If you pour water here in the plate, the water is going to take the shape of the plate. So what is liquid? Liquid, it takes the shape of the container. Okay, although it is having fixed volume. So suppose the glass contains this amount of water. If you pour this amount of water into the plate, although the volume of the water changes, although the shape of the water changes, the volume remains constant. Okay, the volume does not change here, only the shape will change. Liquids flow and change the shape, so they are non-rigid but can be called fluid. Okay, as solid do not flow and it has a fixed boundary, so they are rigid in nature. But in case of liquid, they change their shape, they occupy the shape of the container, So they are not rigid and they are called fluid. There are two different types of fluid. One is air. Air is also a fluid. Then liquid. Liquid is also a fluid. Okay, air and liquid both are fluid. Basically anything that can flow is called fluid. So air is also a fluid. Liquid is also a fluid. Okay. Now the third state of matter is gaseous state. Gas have no fixed shape or volume. It does not have any fixed shape. It does not have any fixed volume. Okay. In the gaseous state, the particles move about randomly at high speed. So in gaseous state, what happens? There is the intermolecular space is very high. The intermolecular force of attraction is very low. So they move here and there randomly. Suppose this is a gas particle, this is another gas particle, this is another gas particle. This particle is moving in this direction, this one is in this direction, this one is in this direction. They move here and there randomly. Okay. Due to this random movement, the particles hit each other and also the walls of the container. So here, suppose this is a container in which some gas particles are there. So here the particles will start randomly moving each other. For example, if I give you an example, you take a container and put some coins over here. Coin 1 rupees, 2 rupees, 5 rupees coin. Now you try to shake it. You try to shake it. Okay. Inside the container, how this coin will move? Randomly they move each other. They will strike the walls here and there and they will strike among each other. Same thing happens here. Inside the container, the gas particles are there. They move here and there randomly and they strike with each other. Okay. The pressure exerted by the gas is because of the force exerted by the gas particles per unit area on the walls of the container. So the pressure that is exerted on the container by the gas particle is due to the random movement of the gas particle. Okay. Now what is the pressure? It can be calculated by the force exerted by the particles per unit area, because pressure equal to force divided by area. It can be calculated. Okay. Now here you can see picture of solid, liquid and gas. Now see, in this case, in case of solid, the particles or the molecules are arranged in a particular way. The gap between two consecutive particles are very small. Okay. So the intermolecular space is very small. They are very rigid. Okay. In this case, there are particles, but the gap between two consecutive particles, for example this two, is more compared to the solid. Okay. So they do not have enough binding force which makes them solid, but they do have the amount of binding force which keep them with each other. Okay. Like liquid, so they can be liquid. Okay. But in case of gaseous state, the particles are moving here and there randomly. See, the gap between two consecutive particles, it is very high. So as they are totally free, they can move here and there whenever they want to move. You can understand it like this. So it can be understood like this. Suppose there is a room. Inside the room there are, suppose, 50 number of people. Now, in one room there are 50 people. Can they move freely? No, they cannot, because there is not enough space for this movement. So this is the case of solid. Now, out of 50, suppose there are 20 number of people present inside the room. Okay. So compared to this, they can move easily. Compared to this 50 number of people, this 20 number of people can move easily, but they are not comfortable while moving. Okay, so this is the case of liquid. So from this 20, suppose we will take only 5 number of people. So in one room there are only 5 people. Now they can move easily, they can go wherever they want to go. So this is the case of gas. Okay. Now this table is very important. Difference between solid, liquid and gas. From this question you can, from this table you can accept lots of question, expect lots of question. So solid, liquid and gas. First one is solid or rigid in comparison to liquid and gas. These are rigid. These are not so rigid. Liquid is rigid but not so rigid compared to solid. So these are not rigid at all. Now these have a definite shape and volume. Definite volume but no definite shape. No definite volume or shape. Solid particles have low kinetic energy. That means the solid, as because the binding force is very much, they cannot move here and there. Liquid molecule have intermediate kinetic energy. Okay. Here they possesses more kinetic energy, very high kinetic energy, because they move here and there randomly. It cannot be compressed. They can easily be compressed. Liquid, okay, it can be easily compressed. Now it can be very easily compressed. Okay. Here their molecules are held rightly by strong nuclear forces. Here intermediate level, the force of attraction, here it is very weak. Solid present in very dense form, it is intermediate level, density is very low. Solid cannot flow easily, it can flow easily. Okay, it is known for its flowing property only. It flows and evaporate easily. Now the diffusion rate is very low in case of solid. The diffusion rate is very low. What is diffusion? I have already explained you in the previous video. Okay, if you don't remember it, please watch it again. Here the diffusion rate is moderate. Here the diffusion rate is very high. So you should remember this table. It might be asked in the examination. Now, at the end of this video, there are certain points that you keep in mind. Solids and liquids can diffuse into liquid. You can mix a solid with liquid. For example, mixing of sugar or salt into water, they can be diffused. The gases from the atmosphere diffuse and dissolve in water. As you know that in aquatic water, carbon dioxide and oxygen is also present, which is used by the aquatic animals. These gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. Okay. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. As oxygen is dissolved in aquatic water, the animal life, that is the aquatic animal life, is possible. Thus, we may conclude that solid, liquid and gas can diffuse into liquid. Okay. So, solid, liquid and gas, all these three states of matter can get diffused into liquids. The rate of diffusion of liquid is higher than the solid. So, this point is very important. The rate of diffusion of liquid is higher than that of solid. This is due to the fact that the liquid state particles move freely and have greater space between each other compared to the particles in the solid state. So in case of solid state, the particles are very close to each other with a very high force of attraction. In case of liquid, the force of attraction is less compared to solid. Okay. Now if it is asked you to arrange the state of matter with respect to its diffusion, then the rate of diffusion in gas is maximum, then so liquid comes into picture, then solid. The liquefied petroleum gas, that is LPG cylinder that we get in our home for cooking, or the oxygen supplied to hospitals in cylinder, is compressed gas. Okay. The LPG gas that we use for cooking, or the oxygen cylinder, they contain the compressed gas. Compressed natural gas CNG is used as fuel these days in vehicles. So you might have seen this one. Vehicles also use CNG for as a fuel. Okay. Now at last there are certain questions related to this video. The mass per unit value of a substance is called density. Okay, density is equal to mass by volume. Arrange the following in order to increase density. So you need to arrange this one in order to increasing order of their density, that is ascending order of their density. Try it on your own. Okay. To first tabulate the differentiate in characteristics of states of matter. The table I have already provided in the video. Comment upon the following. Rigidity. In the table, all these points are given. All you need to search these points and try to write the answer. Okay. Go through it. give regions. A gas fills completely the vessel in which it is kept. So if a vessel can be filled with a gas completely. Why? Because the gas does not have a particular volume or a particular shape. So in case of gas, the molecules move here and there randomly, that is the region. A gas exerts pressure on the wall of the container. Why? Because of the random movement of the gas particles. A wooden table should be called a solid. Why a wooden table should be called a solid? Because it is having a particular shape and particular volume. We can easily move our hand in air, but to do the same through a solid block of wood, we need a karate expert. Why? Because the solid is having more density compared to the air. The air is less dense, so we can easily move over here. So less, if the density of the material is less, then it is, we do not need much force to break the intermolecular force of attraction. In the air, the intermolecular forces of attraction among the molecules is negligible, so we can push the molecule and we can move easily through the air. But in case of solid, it is not possible for a common person. Now, liquids generally have low density compared to the solid, but you must have observed that ice floats on water. Find out why. This is one of the most conceptual question among these four questions. Okay. Try to search this question on your book or from Google, wherever you want to search, and you can comment me the answer of this question. So here what happens, I just give you a hint of this question. Here what happens, generally, when we solidify a liquid, its volume decreases. As the volume decreases, its density increases. But in case of water, what happens when you solidify water? That means when water becomes solid, that is, water becomes ice, it has a special property or special characteristics that its volume increases. In case of ice, the volume of the ice is more compared to the same amount of water. Okay, now with this hint you can answer this question. So this is all about this video. If you have any doubt, then you can comment me. Thank you and have a nice day.